Thank you very much. So I have to say that this actually is my very first time coming to Pakistan. So really excited. So today I really want to take this opportunity to share some of our research activities on how to use AI and IoT sensing technology to support older populations. So first of all, I think aging is a worldwide challenge, is a grand challenge for all the countries. It's not just for some countries. So here you can see the situation in Australia actually has become very worse. There's lots of older people in Australia, but at the same time, we don't have young people to support them. So on the right side, you can see the three countries, the population projections over the next few decades, right, until year 2100. So I think there's one thing in common for these three countries, right? So what happens? The younger generation become smaller and smaller, and the older population become bigger and bigger. So I also show a little bit of information about what's happening for Pakistan. So for now, I think Pakistan enjoy a very young population. Actually, it's one of the youngest population countries. So you have a large number of young people, and you don't have too many older population. But I think the situation actually changed very quickly. So by 2050, then the people age 60 and above actually will triple from quite 7%. So that means by 2050, there's about 21% of your whole population actually is old. So the other thing you can see then by year 2100, pretty much similar as other countries I just showed. Then you don't have a large number of young population and lots of older people in Pakistan. So question is then how technology we can support them, right? So I think for anybody, the dream, of course, you live longer, but that is really not the only purpose, right? If you live not very well, then you're suffering from lots of problems. That is not good, right? So ideally, people should live longer. They also live well. So the situation is we don't have too many younger generation to help them. So what we can do? So this basically comes towards then how technologies such as artificial intelligence, internet sensing technologies can help them, data processing and so on. So for older people, there's lots of very useful applications. For example, if they have a fall, then the system can quickly know it, the accident, then they take some actions, right? So older people, they become slightly, have a dementia problem, they forget things, then the system can remind them. For example, they forget to take a medicine or they forget to go to outside for exercise, right? So system can remind them to do that. So also I think when people become old, then they become weak and fragile. Then ideally, then lots of things can be automatically done. They don't have to do themselves, right? For example, if we know that an older person is going to go to bed, then the lights automatically turn off. So coming to technology, then there's a few key technologies, research topics in this area. So first of all is how can we detect, understand what's going on, what kind of activities a person is taking. Then particular for hand gesture is very useful. So if we, for example, older person, then if they want to turn off the lights or turn off the TV, then they really don't have to go to the TV, have the remote control, push the button, right? Maybe they just use a hand gesture, then control some device to automatically do this for them. So that is, I think, hand gesture also very useful for older population scenario. So we all know that GPS not working in indoor environment, right? So that's why indoor localization also is very important. It's a research topic then. So obviously, I think many years, then there's lots of technical solutions working on these different topics. For example, people have a computer vision-based solution, right? You install cameras, then from camera, then you can know what's going on. So the other thing, of course, is wearable solutions. Then the person wear something, put something on their clothes, then we also can know the activities. So for all the population, all this technology has limitations. For example, computer vision-based, then there's not only privacy issues, but also the lighting condition, right? So if it's dark, then the computer vision solution is not going to work. But mainly it's about the privacy issues, right? So wearable solutions, then is not only uncomfortable, but don't forget, all the people, they forget the things. How can you realize that, oh, you need to remember to wear some devices? So our solution, I think, the core idea actually is then the older people just live as normal. They don't have to do anything. What we do is then we do something in the environment. We deploy sensors, IoT sensors, then we collect the data, then we use machine learning trying to understand what's going on. So basically it's interpret, right? So that is the whole idea. So I have to say this actually is a long-term research activities in my research scope. It's more than 10 years. Then along the way, then we have received research fundings from Australia Research Council and other state government funding. So next few slides, I just report some of our research activities and the results in activity recognition, in indoor localization, hand gesture recognition, and other relevant research outcome. So the first one, you can see our solution for human activity recognition. What we did is then we deploy RFID tags in the environment. Then readers, of course, read the RFID signals. Then we perform any actions that actually cause this RFID signal change. So then we use machine learning trying to learn the patterns for a particular action, right? So if you learn this pattern, later the system can do the prediction if a person performs similar activities. So this is how our system works. You can see in real situation on the top right, that is a person in real situation performing different actions. Then you can see the RFID signals changing. Then this virtual avatar actually is our system, the prediction result. You can see that when person perform different actions, actually our system can accurately predict what he's doing. So this is another research activity related to activity recognition. Particularly, we use Keynote for Microsoft. So this is a camera, but it's not a normal camera. They don't give you videos, give you images. They give you a data stream. It's a streaming data. So what we did is we first from this streaming data, we extract the skeleton information about the human body. Then again, we perform actions. Then we use machine learning or deep learning algorithms to learn what's the pattern for a particular action. If you kick your leg, you throw your arms, you wave your hands, and so on. So then, of course, we can do the prediction. You can see this is our testing. Then we perform different actions. Then our system can quickly detect what he's doing. So for indoor localization, again, what we did is we just use RFID tag. You can see that a small white paper is a small RFID tag, right? So it's an array. Then we present in different locations. Again, that is called RFID signal change. So then the core idea is then behind how can we use machine learning to learn these patterns. If you learn these patterns, then you can predict his location. So as I mentioned, hand gesture recognition is very important for older people because ideally they don't have to do things, right? If they want to turn off the TV, then they just prefer some action, right? So a hand gesture action. So if we can recognize a particular hand gesture, then we can control actuators to do something for them. So again, for hand gesture recognition, there's lots of solutions in this area. Computer vision based, as I mentioned, there's a lighting condition, there's a privacy issues and so on. Then wearables, they have a dedicated device to do that. Sometimes they use a Wi-Fi based solution. So they all have constraints, right? So Wi-Fi based, what happens if you don't have Wi-Fi? Your solution cannot work. Wearables is not good for older people, not only not comfortable, but also people forget to wear them. So this is our solution. I think this still is one of my best research. So what we did is then we just use two things, speaker and a microphone. Think about it. So pretty much nowadays, every modern computing devices, your mobile phone, your tablet, your laptop, they all have these two things, right? Speaker and microphone. So what we did is we use these two things, have a sonar system, okay? So then we perform hand gesture, then they cause this very famous physical phenomenon called Doppler frequency shift, right? So then if you can develop some machine learning algorithm trying to learn the patterns behind this shift, then at the end of the day, you can do the prediction. So that is the whole idea. So yeah. We do have a video you can see. This is our system, how this works. Right here, you can see the person performing different hand gesture action. Then you can see the Doppler frequency shift. So then in the right bottom, actually is our system prediction results. The system think, oh, you're performing a particular hand gesture. So why we play Lady Gaga video? Because our system actually use high frequency, not affect people's normal conversation. You can still listen music, you can still talking to your friends. Our system actually works. So that is indoor localization, hand gesture recognition, and human activity recognition, our research. Of course, we touch different topics. So next two slides, I briefly report some of other activities. The first one is mind control. This is like a fiction, right? But its technology is realizable. We can realize this. For example, older person, they have some serious issues. They cannot move. They only can stay on bed. So then, for example, he wants a cup of tea. That is in his mind. In his mind, he say, oh, I want a cup of tea. Then how to do that? Then if the robot can understand, oh, he wants a tea, then the robot can go make a cup of tea and bring the tea to the older person. So the whole technology part is then we collect brain signals, then we use deep learning to learn the signal change, then we can read his mind, what he wants to do. So we do have a few papers published. If you're interested, please have a look. The second one, of course, robotics, I think is a very important research direction. So end of the day, I think all those technologies then integrate in the robots, right? The robots actually is a friend, is a company. Then they can talk to older people. If they feel alone, then they can do lots of things for old people. So here, I just want to show another short video, just a showcase of our recent research about robotics.
Hey, Annika, how are you?
I'm feeling chipper, thank you. How about you? What's been the highlight of your day so far?
Do you remember me?
Hey Penny, everything's going pretty swell on my end. How about you? What's new in your world?
What's this in my hand?
Door.
Could you repeat that?
Door.
So of course, there's lots of research topics in this area.
What am I doing?
Washing dishes. Not everyone's cup of tea. A. I can see why it might not be your favorite task. It's quite the chore, isn't it?
And now what am I doing?
Oh, badminton. That's a lively game. Keep those birdies flying. Just remember, even if you don't enjoy washing dishes, it can be a peaceful moment in the day. You've got this.
Yeah, so the last part, I really want to mention future directions around this area because the timing, I only mention one. So it's a conversational IoT. The whole idea is to combine conversational AI, such as large language models, together with IoT is a really promising research area. There's lots of very exciting applications. For example, the people just talking, right? So things can be done. So you may ask then, oh, large language models is so powerful, right? I think many of you perhaps already use large language models, right? ChatGPT seems can do lots of things for people, right? So what is the research challenge in this area? What do you need to do, right? So I think here, the fundamental question is that we need to ask ourselves, is large language models perfect already? Right, that is the question. Actually, it's not. There's no perfect large language models today. So there's lots of challenges still there. So one thing is, because I think if you do something automatically, smartly, intelligently, then first thing is reasoning, right? So that's why the first question is correct large language models can do the reasoning very well? That is the question. So the answer actually is no. Yes, the large language models actually cannot reasoning very well. So this, of course, is not only my observation, but also there's lots of people, as they talk about that. Particularly recently, today, this year, Apple, a bunch of Apple researchers, they have this paper party. They test all the major large language models on their reasoning capabilities. So for example, this one, right? So if you count how many kiwi fruits a person pick, right? So it's really not about it's small or big. It doesn't matter, right? It's irrelevant information. So, but as you see, when large language model try to solve this problem, then they count it. So that clearly is wrong. So second major question is, can we trust large language models? I think this is a serious challenge. So anybody use large language models, if you have experience, I guess largely you should agree what Peter mentioned in communication of ECM and show opinion paper, right? So many cases, large language models are talking about some nonsense, and they just very confidently talk about those kind of things, right? The other thing, of course, very frequently, they made up things. Then it's not true. It's not the facts. So all this actually is a challenge. Then how can you solve it? So I think from research point of view, then researchers, we need to do lots of work to make sure that large language models have very strong reasoning capabilities, which currently they don't have too much. And we need to trust large language results. So obviously, I think around this area, there's so many technical challenges that I don't have to talk about one by one. But I just point to you that several years ago, we published a paper article in Communication ECM. Then we just identify about 10 top research challenges around this area. So if you're interested, please have a look. So I just want to stop here. If you have any questions, don't have to time to answer now, but in the tea time, please come to me. Then I'm happy to answer your question. I really want to take this final opportunity to mention one thing. So next year, this IEEE World Congress on Services is a very big conference. It's going to happen in Sydney, Australia. So I'm going to be the general chair. So hopefully, please submit your papers and see everybody in Sydney next year. Thank you.